So this is spring 2013 exam 3, question 4. Juicy grapefruit is tossed straight up with an initial velocity of 25 feet per second. Okay, so this is actually just the same as what this is saying over here. The function itself is giving you the same information. The grapefruit is 2 feet above the ground when it is released. So, okay, we don't even, that's just there, it's just reiterating what the formula is already saying. Its height at time t is given by this formula. How high does it go before crashing and splattering all over the ground? It's almost a parabola. Okay? But the reason why I didn't make this a parabola is I wanted to force the students to actually use calculus instead of just, like I keep telling you guys, it's just a vertex. If this were just a 2, then the vertex t would be, so it's going to approximately be this, minus b over, excuse me, sorry about that, minus b over 2a. So t is going to be about 25 over 32, or about 2/3, or somewhere in that vicinity. So if we don't get that ballpark number, then we know something's dreadfully wrong. Okay, so that's where our go-to number is going to be. Let's go ahead and take the derivative, set it equal to 0, solve for t, and then plug it into y. Right? So we grab the calculator. If it were 16 times 2, it would be 32. But 16 times 2.1, so it's going to be close to 32. It's going to be 33.6, oops, I forgot the negative, t to the 1.1 plus 25. Set it equal to 0, and t to the 1.1 is equal to, I'm going to put the 25 on the other side. That's going to introduce a negative sign. Then I'm going to divide by 33.6, which is, oh, but there's a negative there, so they cancel, right? So you get 25 divided by 33.6 equals. So it's 0.744, whatever. Okay, that's good enough. And honestly, if students got that far, they got some credit, because a lot of students didn't know how to proceed from here. Well, what's the reciprocal of 1.1? It's really close to 1. 1 divided by 1.1 equals 0.90909, that kind of stuff. Okay, so if we had 0.909, we raised 1.1 to the 0.909, that should give us back 1. 0.744 to the power of 0.909. So then you get t equals, now I'm going to need a better calculator, calculator advanced, okay, sorry about that. I'm going to need 0.744 to the power of 0.909. Alright, and then that's going to give me 0.7643. Okay, and you see it's not that much different than 0.744. So people who left that in there, and we said it was about close to 2/3 or something. So I mean, it's all in the same ballpark. If people who thought this was a parabola, they didn't. Their answer wasn't too bad actually. Okay, but the question is, how high does it go? So y at 0.7643 is okay, negative 16. Stick that number in there to the 2.1 plus 25 times this number plus 2. So let's pull out that calculator and say 0 minus 16. So I have trouble getting a negative sign into this calculator. 0.7643 to the power of 2.1. Alright, clearly I did something wrong. Equals, alright, to zero this out, I just say times 0. Alright, I'm going to go 16 times 0.7643 to the power of 2.1 equals, this piece is going to be negative, what was that, 9.099, I'm just going to call that 9.1. Okay, and then this is going to be 25 times 0.7643, 19.1 plus 2. So now we're going to put all these pieces together, add 2, and that's going to give us just about dead even. It's just about 12. So I'm going to say, and what were the units? This is applied calc. Ah, it's feet. 12 feet high. Okay.